Okay, this is the assignment 301.3, friction and net force problem set, and I'm going to work through those questions starting with number 1. Number 1 says, an egg is free falling from a nest in a tree. Neglect air resistance. Draw the free body diagram of the egg below. So if we have an object in free fall, which is what this particular question is describing, then we know from the last unit that the only force acting on this egg is the force of gravity. And the force of gravity we always draw as a downward facing vector. So that's all you need is the one vector. It doesn't really care how long you draw it. It just wants you to show that net force in the downward direction. That, of course, is the force of gravity. It's what gives that egg its weight. And the net force, since that's the only force, the net force is a downward net force. Let's go ahead and take a look at number 2 on 301.3. Number 2 says a rightward force is applied to a book in order to move it across a desk with a rightward acceleration. Consider frictional forces, neglect air resistance. So looking at this, I know that I need a rightward force being applied to the book. So I'm going to go ahead and start with an arrow to the right. Again, the length of the arrow doesn't matter. It does matter, though, if it is relatively longer, shorter, the same length. That will matter based on the way the situation is described. And in this particular question, it tells me that the rightward force is applied to move it across a desk, but there is friction. It says consider friction. However, because it tells me that I have a rightward acceleration in the question, then I know that my net force needs to be to the right. So this vector that I just drew for my applied force needs to be longer than the vector I draw for friction. Again, it doesn't matter exactly how long they are, it just needs to be relatively longer, which I have drawn it in that way. However, these are not the only two forces that would be acting on this book. Again, we're on Earth. We're always going to consider the force of gravity. Okay, and then beyond that, we are, and again, it doesn't matter exactly how long we draw it, but we also need to include the normal force because we're moving it across a desk, across a surface. So that surface is going to push back with some amount of force, and that needs to be equal and opposite to the force of gravity that I drew here because all of the motion of this book is horizontal. Vertically, I need my net force to be 0. So this is what my free body diagram should look like, or something like that. If I go down, I can select the forces that I have drawn. Those are gravity, normal force, applied force, and force of friction. My net force, again, in the vertical direction, I should not have a net force. The only net force I have is to the right, and that is why I drew that one longer. And again, we drew that one longer because in the question way up here, it said rightward acceleration. So net force is to the right. Let's go ahead and take a look at number 3. This is number 3, again on 301.3, and we are again drawing a free body diagram. Unfortunately, for some reason, the grid isn't showing up on this one, so that does make it a little bit trickier, but hopefully we can get it figured out. It says, a college student rests a backpack upon her shoulder. The pack is suspended motionless by one strap from one shoulder. Draw a free body diagram of the backpack below. This is important that I look at this word. It is motionless, which means it's not moving, and that means it's also not accelerating. Again, if I have a situation where I have 0 acceleration, I need to have a net force of 0. That's going to happen if I'm motionless, or it's going to happen if the question says constant velocity. In this case, it's motionless, and so we need to just draw forces, but those forces need to give me a net force of 0. Whenever we look at this backpack, of course, gravity is pulling down on it. It's easier to see if they're the same length if I don't draw them too terribly long because the grid didn't print. The upward force on this, and there is one, needs to be equal and opposite. Again, that is because it's motionless. Those forces have to balance. They have to cancel each other out. The gravity force is, of course, the downward one. That upward force is not the normal force. I saw several of you putting things like that in your assignment. But a normal force is from a surface pushing back. This backpack is not on a surface, rather it's hanging by a strap. And that backpack strap is kind of like a rope, and that means we're going to have tension in that strap. Net force, there isn't one, it's 0. This is number 4 on 301.3. It says, you push a crate with a force of 500 newtons to the left, while 300 newtons of friction opposes the motion. This picture might be a bit misleading because the question is being randomized, so sometimes it says to the right and other times it says to the left, and that's not what the picture is showing, so please make sure that you read the question carefully. But it says, what is the net force on the crate? So let's go ahead and draw a free body diagram. In my free body diagram, I'm going to need to show that I have forces acting on this of 500 newtons to the left, and then I have 130 newtons opposing the motion. Again, friction is always opposing the motion of the object, so it's going to be in the opposite direction, but this will be my force of friction. 130 newtons in the opposite direction means to the right. The net force, again, net force is just the sum of the forces acting on the object. So the net force, in this case, I only have forces in the x direction. So my net force is going to be all of my forces that are going to the left plus all of my forces that are going to the right. But ultimately, your net force is the sum of all of your forces. Okay, and you do have to get this sum separately for the x direction and then for the y direction, horizontally and vertically. Now in this case, they didn't give us any forces in the y direction. It is something that's moving along a surface. There are forces in the y direction, but those forces are going to be equal and opposite to each other because we don't have any acceleration vertically. Everything here is happening horizontally. So we do have Fg and Fn because it is along a surface, and of course we do have gravity, but we actually don't have any net force in the vertical direction. So whenever we're looking at these, we're really just looking at the x direction. So looking at this, if I add these together, keeping in mind that forces are vectors, the one to the left, that 500 newtons, I'm going to label as negative 500. I'm going to call the left direction negative, just so that I end up with the answer that I need here. And my forces to the right are going to be positive 130. So negative 500 plus 130 will give me my net force. If we type that in the calculator, that is very dim. Let's see if I can get a light on it. Okay, that's a little bit better. There we go. Okay, so negative 500 plus 130 gives me negative 370. Okay, and again, the negative sign is a direction. In this case, I chose left as to be my negative direction. So this is really 370 newtons to the left. And that's the wording in the question. Whenever we actually go to put in our answer, it has a spot for us to label that direction. And so we actually just need to indicate left rather than typing the negative sign. In fact, I don't know if it actually wants a negative at all. It might count it wrong. If it gives you a spot for you to type a direction, it wants you to specify it in the same way the question did. And since the question used the term left, it wants us to use the terms left and right. Okay, so 370 newtons to the left. The second part of this question says, if the crate has a mass of 30 kilograms, what is the magnitude of the acceleration of the crate? Okay, again, I can solve for acceleration because I have this equation, F net equals m times a. So as long as I know my net force, which I just found, okay, and I know the mass, I can find the acceleration. The mass is, of course, in the second part of the question. It is 30 kilograms. So let's go ahead and plug into my equation. My net force is, again, negative 370 or 370 newtons to the left. My mass is 30 kilograms. Again, that's in the second part of the question, and we're looking for A. To solve for A, I need to isolate that variable, which means I need to divide both sides by 30. And when I divide both sides by 30, I get negative 12.3 repeating. And again, that negative sign that I just got doesn't mean that it's a negative number. It means it's going in the negative direction, which again we defined as to the left. Okay, but my acceleration would be negative 12.33 meters per second per second. However, this question says, what is the magnitude of the acceleration? So although I do have a direction here, I don't actually need to specify it when I type my answer. Rather, they want me to give the absolute value of it, just the magnitude, the number value. So I'm not going to type the negative sign because it tells me not to. So let's go ahead and submit. All right. Question number 5. Anushka kicks a 0.22 kilogram ball, causing it to accelerate from rest at a rate of 89.9 meters per second squared to the right. What is the net force acting on the ball? Let's start with that question, and then we'll take a look at each of the other pieces to this problem. Okay, so taking a look at that, I need to get a new piece of paper, so give me a second. Okay, so we have a situation where we have this ball that has a mass of 0.22 kilograms. It accelerates at 89.9 meters per second squared to the right. Okay, and we want to find F net. Okay, well that's pretty straightforward because that's going to use the same equation we've been using. F net equals m times a. So substituting in, we are going to say F net equals my mass, 0.22 kilograms, multiplied by my acceleration, 89.9 meters per second squared. So if I multiply those two things, put this over here so we can actually read it, 0.22 times 89.9 gives me 19.778, and that would be my net force. My net force will be in the same direction as my acceleration. My acceleration was to the right, so my net force is to the right. In this particular question, you are explicitly told to include the sign to indicate direction, and it's still going to ask you down here. So unless it tells you to do this, usually you don't actually have to indicate the sign here if you're indicating direction elsewhere, but in this case we have to. To the right is the positive direction, so I don't have to do anything other than type that number, 19.778. And you can type the whole thing, or you can actually round it to 19.78. The unit for force is, of course, the Newton, and this is going to be to the right, if I can spell. Okay, so that's the first question. The second question, and actually let me go ahead and write it here. So my net force is 19.778 newtons. Okay, the second question says if Anushka kicks the ball with a force of positive 20.5 newtons, what is the force of friction between the ball and the ground? So this is the net force acting on the ball. This question is telling me that she's actually kicking it with more force than this, which makes sense if there's friction. Because if there's friction, let's go ahead and draw this in a free body diagram, then she has the force she's applying going this way, okay? But some of that force is being used to overcome the friction, okay? And so although she's kicking with 20.5 newtons, the total ends up only being 19.778, okay? Again, makes sense, hopefully. But let's go ahead and label. So she's got 20.5 newtons of force here, and we have some amount of friction here. And that's what we're going to find. And some of you guys were getting stuck on this because you were looking over at the equations on the board and you were seeing, hey, force of friction is mu times Fn. And you were like, I don't have mu. I can't find force of friction. Yes, you can. Okay, you can find force of friction because you know the net force and you know there's only two forces to consider and you know one of them. So of course you can find the third one. Because net force isn't just equal to MA. Net force is also the sum of your forces. Again, that means that my net force, and here I'm dealing with the x direction, so my net force here, F net, is equal to my forces that are going to the left plus my forces that are going to the right. It's the sum of my forces. Okay, again, we do this separately in the x direction versus the y direction. Right now I'm only looking at the x direction because I don't have any forces to consider in the y, at least none that matter. Okay, again, we have a ball moving along the ground. I do actually have forces, but they're going to be equal and opposite because all of my acceleration is happening in the horizontal direction. So this is all I care about. Okay, so I know my net force is 19.778 newtons to the right. And so let's go ahead and plug that in, 19.778. We can call the right positive equals my net force to the left, or my forces to the left rather. I only have friction, but I don't know what it is yet. Plus my forces to the right, I have 20.5 newtons that is applied. That's the only force that I have to the right. If I had other ones, I would need to add all of them, but I just have this one. And again, we're calling that the positive direction. So this is what I have. 19.778 equals force of friction plus 20.5. This is super easy now to solve because all we have to do is subtract 20.5 from both sides. When I do that, I'll get my force of friction. And I am about to get a negative number, minus 20.5, and I should get a negative number because my force of friction is in the negative direction. So it's a pretty small number. My force of friction is equal to negative 0.722, and again, that's going to be newtons because it's a force. So let's go ahead and put that in here. Force of friction, negative 0.722. My unit is the newton. The direction of the force of friction is to the left. And then the last question is, what is the weight of the ball? Well, when I drew my diagram earlier, I already mentioned that technically we have forces here, and one of those is weight, Fg. The other one, of course, is the normal force, Fn, and I said that those would be equal and opposite to each other. But they're not given to me in the question. I can still solve for them. I have a formula for weight. Fg, or weight, is equal to mass times gravitational acceleration. And on Earth, this number for little g is negative 9.8 meters per second squared. It's our gravitational acceleration. Okay, so if I want to solve for weight, I just need mass, and then I can multiply it by negative 9.8. And the mass was given to me earlier, all the way up in the first part of the question. I wrote it down right here, 0.22 kilograms, but look, I'll remind you, it's way up here, 0.22 kilogram ball right there. Okay, so if I want to find the weight of the ball, all I have to do is multiply that mass, 0.22, times negative 9.8. And I get negative 2.156. Again, weight will always be a negative force. When we draw force of gravity, the Earth is always pulling down on us. That is the negative direction. However, this question says give only the magnitude of the weight force. So I'm just going to type 2.156. This problem does have several steps. I would expect a potential free response short answer question on your test to look something like this. At least that is a possibility. All right, let's take a look at this one. Anika pushes a 7 kilogram box with an applied force of positive 118.5 newtons to accelerate it from rest. If the coefficient of friction between the box and the floor is 0.543, what is the force of friction acting on the box? All right, so we know that we have some different forces acting on the box. Let's go ahead and start with our free body diagram. We know that we have an applied force of positive 118.5 newtons, and that she is accelerating the box across the floor because it says the coefficient between the box and the floor. Okay, so I know that she's applying her force in this positive direction, and it's 118.5 newtons. Okay, I know that there is friction. I don't know how much friction yet, but I know that there is friction. Okay, but I know that the friction will be smaller than the applied force because it says she accelerates it across the floor. Okay, so I know this arrow is shorter. I just don't know exactly what the value is yet. I also know that I have gravity, Fg, because my box has weight. And I know that I have Fn because it's along a floor. We're accelerating it across the floor, and I know that it's just accelerating in the horizontal direction, so I know my vertical forces are going to cancel each other out. They're going to be equal and opposite. Okay, so with this information, I only have one number labeled on there, but I do have one other piece of information. They gave me the coefficient of friction that exists between the box and the floor as 0.543. So we're trying to solve in the first part for force of friction. And we have an equation for that too. Force of friction is equal to mu times Fn. And I have mu. It's right here. What I don't have is Fn. And I don't even have an equation for Fn. Okay, I do, however, know that Fn and Fg have equal magnitudes, opposite directions, but equal magnitudes. They're the same number. So I know that I can figure out Fn if I find Fg. And guys, this is where you have to be able to go through this thought process. If you go through all the steps I've already done and get here, you should be able to say, hey, I can't find this, but I can find this. And you need to be able to have that thought in order to answer questions like this one. So let's go ahead and solve for Fg. We do have an equation for Fg. It's mass times gravitational acceleration. I have a mass. It's in the question, 9 kilogram box. And gravitational acceleration is negative 9.8. And so if I want to find Fg, it is simply going to be 9 times negative 9.8, which is negative 88.2. Again, it's negative because this is a downward force, but I really want this one. This one is positive 88.2. So I have negative 88.2, and I have positive 88.2. Equal and opposite, so that those two were balanced because, again, my acceleration was only happening horizontally. Okay, so from here, now I have Fn, I have mu, I can solve for force of friction. Okay, last time I found force of friction differently. I had to use the free body diagram and the net force. This time I have the information to actually use the equation. Sometimes it's one way, sometimes it's the other. You need to be able to do both. 0.543 multiplied by Fn, 88.2. So we're going to take my answer and we're going to multiply it by 0.543. Again, ignore the negative here because I didn't bother getting rid of it before I typed that in. And I have 47.8926. So my force of friction is 47.8926 newtons. Okay, now it is actually a negative number because friction is in the negative direction. And it does actually want me to type the negative number, so I actually can add that back on. But you're going to determine whether it's negative or not by looking at your diagram, not by looking at the number on the calculator. Okay, so force of friction, negative 47.89, and I can round it there, or I can add the 26 newtons. Again, the direction that it's acting is to the left. And that's the first part of this question. The second part is, what is the acceleration of this box? Again, I can find acceleration because I have this equation, F net equals m times a. So as long as I know the mass and the net force, I can find acceleration. I don't have the net force given to me, however, I just found my force of friction. And I already knew my applied force. So I can find my net force by adding those forces together. And then I can use the mass and solve for the acceleration. So before we can actually use this equation, let's go ahead and solve for what our net force is. Again, net force is the sum of my forces, keeping in mind that forces are vectors. Force of friction is my only force going to the left. It is negative 47.8926. And we're going to add to that my force to the right. I only have one, 118.5. Again, I don't have any forces to consider here because I already know those cancel. When we do our net force, we do have to analyze horizontal and vertical separately. All right, so I need to take my negative 47.8926 and add 118.5. When I do that, I get 70.6074, and that is my net force. So let's go ahead and write it out. F net is 70.6074. You'll notice that I am not rounding any of my numbers, and that is because whenever I want to enter something into MyOpenMath, it does require me to enter my answers to the hundredths place, 2 decimals. But if I start rounding numbers up here and then using rounded values to solve for values down here and then using rounded values to solve for here, I may end up being off. So I'm going to stick with the whole value that's actually in my calculator without rounding it for all of my calculations. I have my net force. Let's go ahead and plug it in over here. 70.6074 equals my mass, and the question was 9, and we're looking for A. Divide both sides by 9, and that'll give me my acceleration. So divided by 9, and that is 7.84. This one I'm allowed to round. This is the last thing I'm looking for, but my acceleration is 7.845 meters per second squared. You'll notice I have a positive number, and that is because my net force was positive, and so is my acceleration. They're both to the right. So let's go ahead and type it in. 7.845. You can also round this to 7.85, or you can just leave that extra decimal on there to be safe if you want. Meters per second squared, or meters per second to the right. It does say to put a plus sign or minus sign in front of your answer. The plus sign is actually optional to type. It will score it correctly even if I don't type a plus sign. But you can if you want to put one in front of that. This is question number 7 on 301.3. It says, what is the magnitude of the force of friction on a level surface that an object receives if the object has a mass of 22 kilograms and the coefficient of friction is mu is 0.47. All right, so I know that we're on a level surface. I know that the mass of this object. I know the coefficient of friction. So I have my object. I have the force of gravity. I have the normal force because I'm on a surface. I know those are equal and opposite to each other. So there is my Fn. Here is my Fg. It doesn't mention anything about it being pushed or anything like that. So this is really just asking us, what the maximum amount of friction the surface would have is. Like, how hard would you be able to push to get it to move? Which we haven't really gone into yet, but that's okay. You can answer this regardless of whether or not you understand that concept. Because, again, our formula for force of friction is mu times Fn. Okay, so we don't have to actually know how hard we're pushing in order to solve for this. We already have mu. It's 0.47. It's in the question. Fn, we don't have an equation for. Again, that's normal force, not net force, Fn. Normal force, we don't have an equation for. However, we do know that it's equal and opposite to Fg so long as our object isn't accelerating vertically. It's not. It's on a level surface. And so in order for us to do this, we just need to find Fg, which again is weight, and weight is equal to mass times gravitational acceleration. So although we don't have the weight, we do have the mass. It's in the question, 22 kilograms, and acceleration due to gravity on Earth is 9.8. More specifically, it's negative 9.8. So if we multiply that, 22 times negative 9.8, we're going to get negative 215.6. So the weight is going to be 215.6 newtons downward. The normal force is going to be 215.6 newtons upward. Okay, and now that we have normal force and we have mu in the question, we can solve for force of friction. So my force of friction is equal to, my mu is 0.47, and we just determined the normal force to be 215.6. And so if I want to solve for my force of friction, 215.6 times 0.47, and I get 101.332. That would be my force of friction. My unit will be newtons because it is a force. Okay, I did not indicate a direction here because I actually don't know which way the force is being applied. Because again, friction will oppose motion, but it doesn't tell me which way it's being pushed. I'm just solving for the magnitude of this value. So let's go ahead and take a look at the next one. 301.3, number 8. In a physics lab, Ernesto and Amanda apply a 136.1 Newton force to a 7.5 kilogram shopping cart to accelerate it across a horizontal surface at a rate of 3 meters per second squared to the west. Okay, so let's start with a diagram so that we can kind of see the forces acting here and then see if we can find net force from that or if we need to calculate it. Okay, so we know that Ernesto and Amanda are applying a force to the cart that causes it to accelerate to the west. So we know, I'm going to go ahead and use north, east, southwest, kind of the way that you would normally draw a compass rose. So I'm going to say this is west, and I'm going to label their force as 136.1 newtons. It does not mention friction in the first part. However, the second part does ask for the force of friction, so I'm not sure. I'm assuming there probably is friction here just based on the fact that I'm being asked for it, but I don't actually know yet. So let's go ahead and label the other forces that I know are present. I know that I have Fg because I know that there's a weight to this cart, and I know that I have Fn because I know that this cart is accelerating across a horizontal surface and therefore there is a support force. And I know the acceleration is horizontally and not vertically, and so I know these vertical forces are equal and opposite so that they cancel out. Okay, again, I probably have friction over here, but let's go ahead and see what I get for my net force. Again, I can't actually solve for it from this picture because we're not told anything about what the friction is. So the other way to solve for net force, apart from using that diagram, is to use the equation. F net is equal to mass times acceleration. And they did give me those pieces of information. They gave me a mass of 7.5 kilograms. They gave me an acceleration of 3 meters per second squared to the west. I'm going to go ahead and call the west the negative direction since I drew it up here in the negative direction. 7.5 times -3 gives me a net force of -22.5, or the way that it's going to want it here is 22.5 newtons west. We're going to use the same type of labeling that's in the question. 22.5 newtons west would be my net force. So based on that, I know there's friction. There has to be, because this is 136.1 newtons, and yet my net force is only 22.5. So the amount of force over here cancels out almost all of this, because I only have 22.5 newtons left that's actually doing something. Okay, so I know that there's friction now. It was kind of implied based on the fact that they're asking me for it, but I didn't know. But I know that this number is only 22.5 newtons smaller than this one. And again, I know that because the other equation that we have for net force is that net force is the sum of my forces. My forces to the left plus my forces to the right, keeping in mind that forces are vectors. Okay, so force left plus force right. Okay, so looking at this, my net force, we found it just a second ago, -22.5. Again, remember I'm using the negative sign to indicate to the west, equals my force to the left. I do have one. It is -136.1 plus my force to the right, and that's going to be friction. That's the only force that I have mentioned there. And so I can solve for friction now. I have -136.1 being added to it, so I just need to add 136.1 to both sides so that it can cancel over here. So my calculator plus 136.1 is going to give me a force of friction of 113.6 newtons to the right. Okay, and again, that makes sense. It's almost the same size. I told you it almost cancels out the whole thing. Okay, and it does. It's only 22.5 newtons smaller. So my force of friction is 113.6. My unit, of course, is newtons, and the direction here is east. It's to the right in my picture, but we're using the cardinal directions based on how the question is worded. All right, this is number 9 on 301.3, and it says, according to the free body diagrams above, which of the objects would be accelerating to the right? Select all that apply. All right, so we've looked at these diagrams before. Looking at these diagrams, I do not know the direction of the velocity of the object. I don't know if the object is moving up, down, left, or right. I do, however, know which way it's accelerating, because the acceleration will always be in the same direction as the net force. And so if I'm looking at these, I need to determine which diagrams show net force to the right, because if it has a rightward net force, it will have a rightward acceleration. So looking at them, A is, they're all going to cancel. That's a net force of 0. B, however, has 20 newtons to the right and only 15 to the left. So it does have a net force to the right, and B would therefore accelerate to the right. C would not have any acceleration at all. Again, this is a diagram showing a net force of 0. These cancel each other out. It's balanced. So that one could not be accelerating to the right. But of course, the last one could be. D, it has a net force to the right as well. So again, I don't know if it's going to the right. I just know it's accelerating to the right. So just to clarify, object D, for example, could be moving to the right. And if it is, it's getting faster. But it could just as easily be something moving to the left and slowing down. It could be you riding your bike and then you stop pedaling and just kind of coast, and friction is now opposite your motion. But you're still moving to the left and you're just going to slow down. Okay, so it could be that type of situation. Oops, I guess I already submitted it. All right, that is the last question for this assignment, so hopefully that helped to clarify any questions that you guys may have had.